This block focuses on furnaces as a potential ignition source, not assuming failure but evaluating them scientifically. Furnaces are common heat-producing appliances found near areas of origin, especially basements, utility rooms, attics, and closets. Our goal is to understand how furnaces operate, how they fail, and how to properly examine them in accordance with NFPA 921 without over-attribution. By the end of this section, investigators should be able to identify furnace types, explain how they operate, and perform both external and internal examinations safely. Emphasis is placed on recognizing legitimate ignition mechanisms versus incidental fire damage and applying NFPA 921 methodology throughout the process. Furnaces are heat-producing appliances and therefore must always be considered, but not presumed, as a cause. They are often located near the lowest point of a structure where fire patterns may converge. Investigators must distinguish between damage to the furnace and damage caused by the furnace, which requires systematic evaluation. NFPA 921, Section 16.2.8.6.2 requires that all heat-producing appliances be photographed, regardless of initial suspicion. This includes documenting control positions, wiring, cords, and outlets. Even if the furnace is later eliminated, failure to document it can undermine investigative credibility and completeness. NFPA 921 recognizes several furnace types. Central forced air units are most common, but floor furnaces and wall furnaces are still encountered, especially in older housing stock. Each configuration presents different heat transfer paths, clearance issues, and fire spread considerations that must be recognized during analysis. Understanding fuel type is critical to determining ignition mechanisms and failure modes. Natural gas and propane involve piping, valves, and combustion systems. Fuel oil introduces storage tanks and pumps. Electric furnaces eliminate combustion, but introduce electrical ignition potential. Each fuel system brings different investigative considerations under NFPA 921, Section 7.10.1.1. Standard efficiency furnaces typically use metal flue venting and natural draft, resulting in higher exhaust temperatures. High-efficiency furnaces use sealed combustion, induced draft, and PVC venting with condensate production. Investigators must understand these differences to properly assess venting failures, heat transfer, and condensation damage. Interview occupants to gather background information, not to assign blame. Ask who installed the furnace, when it was installed, and whether permits or inspections were completed. Improper or unpermitted installations can introduce clearance, venting, or fuel supply issues. Determine maintenance history, including recent servicing or repairs. Pay close attention to any work done shortly before the fire and document who performed it. Ask about operational problems prior to the incident, such as unusual noises, odors, short cycling, pilot issues, or frequent shutdowns. These may indicate airflow, venting, or internal component problems. Finally, establish who last operated or adjusted the furnace and whether it was running near the time of the fire. Interview information should support, never replace, physical evidence, and must be evaluated using the NFPA 921 scientific method. Begin with a non-intrusive examination. Evaluate cabinet damage, clearances to combustibles, and surrounding fire patterns. Look for indicators of overheating such as discoloration, warped metal, or localized charring. External observations guide whether an internal examination is warranted. Be sure to document any labeling found, and also document the surrounding areas around the furnace. Internal examination should only occur once the scene is safe. Remove access panels carefully and document their condition. Examine burners, igniters, wiring, control boards, and safety devices. Investigators must differentiate between fire-induced damage and pre-fire failure indicators. NFPA 921 Section 10.7.2 emphasizes that venting systems must remove combustion products and prevent overheating or condensation damage. Improper venting can elevate internal temperatures, damage components, or contribute to fire spread. Always examine vent paths, terminations, and clearances. Heat exchanger degradation can allow excessive heat to escape into the furnace enclosure. NFPA 921 Section 7.10.4.8.4 notes that elevated enclosure temperatures may ignite nearby combustibles. Investigators should document exchanger condition, but avoid destructive testing unless justified and coordinated. Furnaces must be evaluated systematically using the scientific method. External and internal examinations, venting assessment, and fuel system evaluation are all essential. Proper documentation and adherence to NFPA 921 protect both investigative accuracy and professional credibility.